Well, hello. I'm honored to be here with you today. We have a very short amount of time to talk about an incredibly important topic, and that topic is namely the future of work and how we can design technology to optimize for the best possible future. Now, this title is perhaps a little bit misleading. It seems like a prediction as if the future is already here and already decided, and that's useless because, of course, no one can predict the future. Auch ist die Bedeutung dieses Titels vielleicht ein bisschen ist nicht stark genug. So we can try to make it stronger. We can say the future must be plural, must involve collaboration, although that seems a little bit too assertive, as if I'm insisting about what the future will be like, and of course no one can really insist, no one has the right or the ability to insist on the future. So in the spirit of the technology that we're going to take a look at today, and the philosophy, the design philosophy that Oblong Industries uses with its technology, let's try something else, which is that I will try to persuade you, this talk should persuade you about the nature of the future, that's important. And once you're persuaded, then we can work together, we can collaborate to bring that future about. So here's the persuasion part. The future of work really, really needs to be plural. It needs to involve collaboration. Why collaboration? Well, I think the era of single, isolated geniuses is over. The future that we're interested in and the future that's beginning now will require, for business, for successful businesses, for the ideal and desired business outcomes, those futures will be based exclusively or principally on collaboration. The future of government, successful civic projects will require mass-scale collaboration. The future of culture and science will depend on people being able to collaborate in entirely new ways. And it's possible that, given the problems that face us right now, the future of human civilization itself will require collaboration on an entirely new level. And that means that teams will need to work together in more profound and dense ways, that teams will need to intercollaborate across distance. And so what we're looking at is a situation in which the very most extraordinary collaboration that you might see today, that you might read about in a white paper or a Harvard Business Review article, must become ordinary. That must become everyday collaboration, and technology must support it. So technology should be able to support it, shouldn't it? Well, it turns out that today technology is doing a terrible job. Technology is actually standing in the way of collaboration. How do we know that? We know that because every device, every computer you use is designed for only one person at a time. So it's the opposite. Collaboration is the opposite of what these devices think. How do we know that? We know that because the user interface for all of these devices thinks only about one person at a time, you. It's like the most faithful dog or the most faithful pet in the world. It only knows about you. And user interface is therefore where we need to focus. I've been obsessed with user interface for 25 years. And user interface is such a critically important piece of the equation because when you're a human being, as we are, and you use computers, the UI is all you have. Everything that you see and understand about the computational process comes to you through the UI, and the only way you have to speak back to the machine, the only way you have to control the machine is through the UI. So for us, the UI is the computer, and if it's a weak UI or a not capable UI, then we become weak and incapable. What we need is the opposite of that. We need UIs that enable us, that amplify our intelligence. And so when I designed the future computer for the film Minority Report, what I was trying to do, my personal mission, was to show the world that user interface could be exciting and it could be powerful. It could extend the intelligence of some very capable people. So there's no AI here. I'm afraid I'm in the wrong session here in the AI session. There's no AI, there's just really, really smart police detectives. And using this UI, they're able to access more information, they're able to make better decisions, and they're able to work together. If you go back to these scenes and watch them again, you'll see that it's not someone working alone. You see more of Tom Cruise because he's a higher paid actor, so we have to see him more. But there's a small team in this room, an expert team that's collaborating to solve an incredibly time-sensitive problem. At Oblong Industries, we're also obsessed with collaboration, and we're obsessed with the idea that UI is, again, the key to collaboration. Building new kinds of UIs that, for the first time, think about multiple people, that allow multiple people to use them at the same time. So let's go through 5 very brief video examples of technology. 2 will describe just basic principles, basic design opportunities that Oblong software stack makes generally available. 2 are prototypes. 2 are R&D pieces that point the way toward future. And maybe most importantly of all, the final example will be an actual product, a way to get these ideas out into the world and to benefit organizations, businesses, governments, and teams today. So the first idea is that we need to make space for more than one person. We need to make space for collaboration. Here's a system that allows gestural control of a simple data set, but because there are large screens, because there's a big pixel space, we can step back and multiple people can stand side by side and operate the data space together, not one at a time, not serially, but in parallel. That idea of working in parallel is something that's very easy for human beings. We do it all the time in the physical world. It's only computers that stop us from working in parallel. So we have to re-parallelize our lives in the digital realm. That's number one. So we need a multi-user AI. That's just basic. We have to allow more than one input at the same time. Number two, the way we understand the world is based on the world. We understand the world through space, spatially. We need to teach machines about space. We need to make a spatial computing environment. So what you see here is an interesting demonstration of a small piece of media that's running around 5 different screens. There are no longer any boundaries. And what's important is that the experience that the user gets is exactly what she or he expects. So now, we've moved beyond the old way of thinking, which is that computation stops at the boundaries of this device. Of course, it doesn't have to. What we need is to make a continuous data space. As much as we want, if we need more pixels, we just add more screens, and it doesn't matter what operating system is running. It doesn't matter how many CPUs are involved. We need all of that to work. We need data and programs to become interoperable across space. We understand the world in space, so the computer needs to understand space as well. Spatial computing is critically important. In the third example, what we're going to look at is it's a much more complicated example, much more sophisticated, but we'll take a look at one piece, which is a new kind of UI element that helps people understand what other people are seeing and understanding. So the scenario is an urban planning, an emergency first responder situation. This is an incredibly fine-grained scan and simulation of the city of Florence, Firenze. And what you see is 3 different devices are looking at this data space at the same time. So one data space, one simulation, but many different applications looking into it. What's new is that we can take the view from someone else and move it around. So we have an understanding of what a colleague is seeing. This is a very new idea. And once we have a UI element that represents what that colleague is seeing, we can manipulate it. And it's a kind of basic cognitive empathy that we're enabling. If I have a representation of what you're seeing, then I can understand that maybe you missed an important event. And maybe I can take your view as if I were turning your head and drag it to the event of importance. You can imagine this scenario, of course, with more than one human. The video is shot with just one human for clarity purposes. So again, the idea is a kind of cognitive empathy, a kind of situational empathy. I need to understand not only the big space, but I need to understand what you're seeing and how you see the world. This can be the beginning of a much more powerful collaboration paradigm. The fourth piece requires a little bit of a logical analogy, and I'd like to attempt that here live before you today. If we think about the command line interface, which we last saw in a really important way back in, let's say, 1982 or 1983, when it was the only interface available, so you type text, text and words go in, and text and words maybe come out. That's all you have. It's kind of one-dimensional. It's very verbal, so it uses the logical and language part of the brain. What happened when we took that command line interface and transformed it into a graphical user interface? Think about 1984, the introduction of the Macintosh. Well, now we have pixels, we've got pictures. We talk to the machine, and the machine talks to us in pictures, and that's very important. But something else even more important happened. So think about the command line interface. It's 1980, it's 1982. You're editing a word processing file. Let's start earlier than that. You're in you're in VisiCalc. You're in the world's first electronic spreadsheet. So you're editing in your spreadsheet, and now you want to send a letter to someone. Well, you literally have to shut down VisiCalc. You have to shut down the spreadsheet program in order to start up the word processing program. And if you then want to get on the proto-internet, you want to use the bulletin board service to communicate with other people, you have to shut down the word processor and start up the bulletin board service. So serialization, again, we've deparallelized in the command line interface. You can only do one thing at a time. That is the nature of the operating system, but it comes because of the nature of the UI. When we go to the graphical user interface, when we go to the Macintosh, you've got multiple programs living in the same space. And now if you take that same scenario, you can edit your spreadsheet, you can copy a bunch of cells out of the spreadsheet and paste them into a Word document that you're editing. And then you can take that entire file, that entire text file, and drop it into email and send it off. So this is not just a convenience, this is a complete change in the way the world works. And it comes about because of the user interface. Let's do the same thing now and ask, if we take that same size step, starting with a graphical user interface, what do we get? We need to square that GUI. We need to do a meta GUI, and what we get is a meta desktop. And that looks like this. It's a large pixel space where multiple people can bring machines, their personal devices, personal computers. It's proximity-based, so when you get close enough, the program and the data that's resident on your personal machine jumps across the gap and starts running on the big wall. And then, if the UI allows it, and if the individual programs advertise their capabilities through this new UI, they can begin to interact. The programs can begin to interact in the shared pixel space, even though maybe they weren't originally designed to work together. So this is now, again, the square of the GUI. This is a pixel space that belongs to multiple people at the same time, and through the GUI, entirely new capabilities are added. So for the final example, I'd like to take a look at the product. Mezzanine is Oblong's flagship product, and it's a much simpler version than anything we've looked at. Really, it combines the first and the second video example, which is collaborative computing, more than one person interacting at the same time, and a spatial environment. And the idea is to produce a computer that works like a room, a computer that multiple people can use at the same time, just as multiple people can enter a room and solve problems at the same time. And that gives people kind of democratic access to the pixels so that they can see the same thing. In a mezzanine room, what's important are the people, the space that they occupy, the amount of pixel real estate that's available. So we want to see more. It's not enough to try to solve the world's most difficult problems on this. This is a great device, but it's not enough space. So give people more space, give people more pixels, and now give them an interface to those pixels that lets them contribute at the same time. 2, 3, 4 people can toss data, toss applications, toss documents into the pixel space, juxtapose them, move them around, control the space. And you get to control the space from any device you bring, a smartphone, a tablet, a laptop, a browser, even a pointing wand that is the legacy of the Minority Report operating system. So in a room like this, you're no longer heads down, where it's impossible to collaborate with other people. You're heads up. You're looking in the same direction. You're looking at the same data. You're making meaning by bringing together different people's ideas, different people's data, different people's documents, different people's applications. And it's in the collision of ideas, in the collision of minds, and the collision of data types that answers can be found and that problems can be solved. And all of this has to happen in a completely natural way. It can't require new knowledge. It has to work the same way that the physical space works. And these systems are now in use by over 100 of the world's largest and most successful companies all over the planet to solve the world's hardest problems, or at least some of them. We'd love to solve more problems with you. So this is the point of view that Oblong brings about the future of work. We're not seeking to replace all of the devices and all of the user interfaces that exist today. What we want to do is augment them. So you have your individual devices, your personal devices. Those are great. Now add to them a new kind of computer that multiple people get to use at the same time, and that lets people work truly in a collaborative way. And to boil it down, the idea is very, very simple. It couldn't be simpler. It's just what the real world does for it. These digital systems allow multiple people to see the same thing at the same time in exactly the same way. And that is the basis of shared understanding. If you can enable shared understanding, then you can enable collaborative work. and you can enable the kinds of outcomes that we would like to think are going to make the future possible. And not just in the sense of dire problems that need to be solved, but also of enormous opportunities. There's an incredible amount of excitement available to us. Computers make that excitement palpable. We live in a digital world. We live in a device-filled world. Those devices should speak to us on human terms and on architectural terms, and they should be exhilarating to use. That's how we will know when we get the future right. Thank you.